real-life problems and situations involving relationship of two quantities can be best illustrated and solved using systems of linear equations. These are real-life problems or situations that can be solved using system of linear equations but not limited to the following. Number problems. In this quarantine time, many were having fun doing gardening. Don't you know that the dimension and the area of a rectangular garden can also be solved using systems of linear equation? If you are comparing two quantities, such as which of the two is larger, bigger, greater than the other, can be best solved using systems of linear equation. Investment problem, mixture problems, and motion problems. Sometimes solving these problems using system of linear equation will make it easier. As we recall, the graph of linear equation in two variables is a straight line. The systems of linear equation in two variables can be illustrated by two lines in the Cartesian planes. Therefore, there are three possible scenarios. The two lines could be intersecting lines, parallel lines, and coinciding lines. As we all knew, graphing linear equation really takes time. Is there another way of knowing the graph of the system of linear equations, whether it is intersecting, parallel, and coinciding lines, without actually graphing the equation? Just stick around and I'll teach you how. If you are new to this channel, kindly hit the subscribe button and the notification bell, and I promise that I will journey with you in learning math lessons in an easy way.
These are our objectives. After watching this video, you are expected to illustrate system of linear equation in two variables, graph a system of linear equation in two variables, and categorizes when a given system of linear equation in two variables has graphs that are parallel, intersecting, and coinciding lines. What is systems of linear equation? System of linear equation is formed when two or more linear equations are considered together or simultaneously. So this is an example of a system of linear equation. So the equation x plus y is equal to 5. This would be our equation 1. And x minus y is equal to 1 would be our equation 2. So if this first linear equation and the second linear equation are put together, we form system of linear equations. The solution to the system of linear equation in two variables consists of an ordered pair, which is x and y, that will satisfy both equations. So in this case, if we try to take a look with equation number 1, x plus y is equal to 5, there are infinite value of x and y that we can assign that the sum is equal to 5. Let's say our x is equal to 0. So what must be our value of y? So that if we add 0 and y would be equal to 5, and that is 5. So the ordered pair is 0 and 5. And lastly, if x is equal to 4, our y is equal to 1, so that the sum must be equal to 5. Now we will consider equation number 2, x minus y is equal to 1. So what are the two numbers that we are going to subtract that their difference is equal to positive 1? So if x is equal to 0, our y must be equal to negative 1. 0 minus negative 1 would be positive 1, so the answer would be 1. So the ordered pair is 0 and negative 1. If x is equal to 4, our y must be equal to 3, so that their difference is equal to 1. The two equations with a value of x and y that will make both equation 1 and equation 2 correct. In that case, that is 3 and 2. As you can see, both equation 1 and equation 2 are satisfied with this value of x and y. So since in the given ordered pair 3 and 2, both equations are satisfied, then we can say that 3 and 2 is the solution of the given system. In your previous lessons, you were taught how are we going to graph linear equation in two variables. We can do it in three different ways. First, table of values. Second, the intercepts method. Thirdly, the slope-intercept method. So let's have an example. So graph the equation x plus y is equal to 5, x minus y is equal to 1. This is the given equation, our first example. So we will do it using the intercepts method. First equation, x plus y is equal to 5. So we will now let y is equal to 0. Then solve for x. X plus 0 is equal to 5. And solve for x. If y is 0, the value of x is equal to 5. So our ordered pair now is 5 and 0. Now let's have the y-intercept of this given equation. Now let the x is equal to 0 and we will solve for y. Substitute x by 0. 0 plus y is equal to 5 and 0 plus y is equal to y is equal to 5. So therefore, if x is equal to 0, our y is equal to 5 and our ordered pair is 0 and 5. Now let's consider equation number 2. Let y be 0 and solve for x. Therefore, if x is 1, our y is 0. So our y-intercept. So we will let x equal to 0. Then 0 minus y is negative y is equal to positive 1. The coefficient of negative y is negative 1. So to make it positive, we will divide or multiply both sides of the equation by negative 1. So negative 1 divided by negative 1 would be positive y. So 1 divided by negative 1 is negative 1. So we have now the x-intercepts of the first and the second equation, y-intercept of the first and second equation. So now we are now ready to graph these two equations in the Cartesian plane. Plot the y and the x-intercept of each equation respectively. So the first point is 5 and 0. The second point is 0 and 5, so it would be here. So connect these 2 points, and we have the equation of the line x plus y is equal to 5. Second equation, so that would be this point. Secondly, if x is 0, y is negative 1. So that would be in the bottom point. Okay? Connect these 2 points, and we have now the graph of the equation x minus y is equal to 1. Where do these two lines intersect? So these two lines intersect at point 3 and 2. So that would be the ordered pair where the two graphs intersect. So in that case, this is the solution to the system. So to conclude, these equations are independent and the system is consistent and the system has a unique solution. Unique or one solution. What is the solution? The point of intersection of the two lines. Example number 3. Graph the equation 3x plus 2y is equal to 6. Then 6x plus 4y is equal to 12. So first, we're going to let y is equal to 0 in the first equation and solve for x. So 3x plus 2y is equal to 6. So substitute y by 0. So that would be 3x plus 2 times 0, and that is equal to 6. So 2 times 0 is 0. So that is 3x, because 3x plus 0 is 3x, and that is equal to 6. Solve for x. We are going to divide both sides of the equation by 3. And that is x is equal to 2. So our ordered pair, when x is equal to 2, our y is 0. So the y-intercept, we will let x be equal to 0. So 3 times 0 plus 2y is equal to 6. 3 times 0 is 0. Then 0 plus 2y is 2y. And that is equal to 6. Divide both sides by 2. So therefore y is equal to 3. Our ordered pair now, when x is equal to 0, our y is equal to 3. Second equation, 6x plus 4y is equal to 12. So our x-intercept, we will let y is equal to 0. So 6x plus 4y is equal to 12. So 6x plus 4 times y would be 0 is equal to 12. So 4 times 0 is 0. 0 plus 6x is 6x. And we just copy 12. Divide both sides by 6 to solve for x. So x is equal to 2. So our ordered pair is 2 and 0. For the y-intercept, let x is equal to 0. So 6 times 0 plus 4y is equal to 12. Then 4y is equal to 12. Divide both sides by 4. So our y is equal to 3. So we are now ready to graph these two equations in the Cartesian plane. So the first is 2 and 0, so it should be here. The second point is 0 and 3, so that would be here. Connect the 2 points, that is the graph of the equation 3x plus 2y plus is equal to 6. Second equation, so the x-intercept is also the same at 2 and 0 here. The y-intercept is also the same as 0 and 3. Connect the dots, and that is the graph of the equation 6x plus 4y is equal to 12. So in this case, the two graphs of the two equations are lying on the same line, and we call it coinciding lines. So if the lines are coinciding, we can say that the equations are dependent, the system is consistent, and the system have infinitely many solutions. Take note, we find the solution to the given system to the point of intersection of the given line. But in this case, since this is coinciding lines and line is made up of infinite number of points, thus we can say that this system have infinitely many solutions. Example number 4. Graph the system x plus 3y is equal to 9, 2x plus 6y is equal to 12. So to do this, we will do it by slope-intercept method, which is the y equals mx plus. For first equation, x plus 3y is equal to 9, we will express this equation in terms of y. So what are we going to do? The x will be transposed to the right side, would become negative x. And we just copy positive 9. So divide it by 3, both sides of the equation. So 3y divided by 3 would be y. Negative 1 divided by positive 3, that would be negative 1 over 3x. Then 9 divided by positive 3 would be 3. So this is now the slope-intercept form of the equation x plus 3y is equal to 9. The slope, it is just the coefficient of the variable x. So the coefficient is equal to negative 1 over 3, and that is our slope. So our y-intercept is just the constant. So our y-intercept, which is b, is equal to 3. So this means that the ordered pair is 0 and 3, because y-intercept is the value of y when x is equal to 0. So plot first the y-intercept. So our y-intercept is 0 and 3. Our point must be here. Take note, we need 2 points to have the graph of the equation of the line. So how do we obtain the second point? We will make use of the slope. So take note, the slope is rise over run. So in plotting this point, our reference is the origin. Now in finding the second point, using the slope, we will start from our y-intercept. From here, our slope is negative 1 over 3. The rise is negative 1. Rise is the movement of the y-coordinate. Run is the movement horizontally of the x-coordinate. From the y-intercept, we will go down 1 unit. So our run is positive 3. So after going down by 1 unit, we will move to the right by 3 units. So the point must be here. So this would be our second point. So since we have now the 2 points, we can have now the graph of the equation of the line. Now let's have the graph of the equation 2x plus 6 is equal to 12. Solve the equation in terms of y. So 6y would be negative 2x. We just copy positive 12. So divide both sides of the equation by 6. So 6y divided by 6 is 1y or y. Negative 2 divided by 6 is negative 1 over 3. Then positive 12 divided by 6 is positive 2. The slope is negative 1 over 3, and the y-intercept is 2. So the ordered pair 0 and 2. So first, plot the y-intercept. The y-intercept is 0 and 2, so that would be here. Our slope is negative 1. Our rise is negative 1, so 1 unit down. our run is positive 3, so 3 units right, and that would be our second point. Connect the 2 points, and that is the graph of the equation 2x plus 6y is equal to 12. So as you can see, these two equations, their graphs in the Cartesian plane are two parallel lines, which means that these two lines do not intersect. So two lines do not intersect if their slopes are equal. So if that's the case, we can say that the equations are independent, but this system is inconsistent. Why? Because the system have no solution. So as you can see, the solution to the given system is the point of intersection. But since these two graphs do not intersect, then this system have no solution. Example number 5. So graph the system 2x minus 3y is equal to negative 5. Then 2x plus y is equal to 7. So by slope-intercept method, so divide both sides by negative 3. So our slope is 2 over 3 and our y-intercept is 5 over 3. The points is 0 and 5 over 3. So to graph this one, so 5 over 3, approximately that is around 1.6. If this is 0 and this is 1, so 1.6 is somewhere here. And that would be our first point. So our slope is 2 over 3 and our rise is positive 2. So from here, we will count 2 units. So since we started the first point somewhere at the middle, so our first unit is at the middle. So this is 1 unit, then second unit. So that would be here. So this would be our positive 2 rise. Our run is positive 3. So from here, count 3 units right because that is positive. So that would be our second point. Connect these 2 points, and that is the graph of the equation 2x minus 3y is equal to negative 5. So the next equation, 2x plus y is equal to 7. So y is equal to negative 2x plus 7. So since this is already y, so our slope is negative 2 over 1. Or that is negative 2. But take note, any number has a denominator of 1. That is why we take slope as negative 2 over 1. And the y-intercept is 7. So therefore, the ordered pair is 0 and 7. So first, we will plot the y-intercept. 0 and positive 7, it must be here. The slope is negative 2. So from here, we will count 2 units down. 1, 2. Then our run is positive 1. So to the right, 1. So connect these 2 points. And that is the graph of the equation 2x plus y is equal to 7. So where do these two graphs intersect? So these two graphs intersect at point 2 and 3. And that is the solution to the given system. In this case, since this is intersecting, the equations are independent, the system is consistent, and the system has a unique solution. And how do we know that a system are intersecting lines, coinciding lines, and parallel lines even without graphing both equations? To do it, we just examine the coefficient of the variables and its constant. And these are real numbers a, b, and c. How do we determine the real numbers a, b, and c? A is the coefficient of x, b is the coefficient of y, and c is the constant. So case number 1. So if the coefficient of x, which is a in the given system, its ratio a sub 1 divided by a sub 2 is not equal to b sub 1 over b sub 2, these are the coefficient of y, we can say that the graph of the system are intersecting lines and the system has a unique solution, which means the intersection of the two graphs. That would be the first case. So second case, if a sub 1 over a sub 2 is equal to b sub 1 over b sub 2, but it's not equal to c sub 1 over c sub 2, then we can say that the graph of the system are parallel lines. So again, if the lines are parallel, no intersection, that means that the system has no solution. Okay? So third case, if A sub 1 over A sub 2 is equal to B sub 1 over B sub 2, which is also equal to C sub 1 over C sub 2, then we can say that the graph of the system are coinciding lines. So if that's the case, the system have infinitely many solutions. Let's determine if the system has unique and infinitely many solution or has no solution. So first, the given equation. So from the given equation number 1, in the equation number 2, our A sub 2 is equal to 1. The coefficient of y, which is B sub 2, is negative 1. And our C sub 2, the constant in the equation 2, is 1. So how do we do it? First, we're going to compare the result of the ratios. So A sub 1 over A sub 2, B sub 1 over B sub 2, C sub 1 over C sub 2. So simplify. So 1 divided by 1 is 1. 1 divided by negative 1 is negative 1. 5 divided by 1 is 5. So we will compare. As we can see, from the first comparison, A sub 1 over A sub 2, its ratio is not equal to B sub 1 over B sub 2. So in this case, we can automatically conclude that this system has a unique solution based on the ratios that I have presented on the different three cases. Thus, we can say that this system has intersecting lines as the graph. And that means that the system has a unique solution. Next example, x plus 3y is equal to 9. 3x plus 6y is equal to 12. So in equation number 1, equation number 2, we will compare, substitute. So simplify. So 1 half. 3 divided by 6 is also 1 half. Then 9 divided by 12 in lowest term, that is 3/4. So as we can see, the A sub 1 over A sub 2 is equal to B sub 1 over B sub 2, but not equal to C sub 1 over C sub 2. So that will fall under the second case. In that case, we can say that the graph of the system are parallel lines and this system has no solution. Now, let's have the last example. First equation and equation 2. So by comparing the ratios of their constants, negative 1 over 3. So 3 over negative 9, 4 over negative 12. Simplify. So all of them are equal. So we can say that this system, the graphs are coinciding lines and this system have infinite many solutions. So to sum it up, this is the given systems of linear equation. So if A sub 1 over A sub 2 is not equal to B sub 1 over B sub 2, so we can automatically conclude that this system, the graphs are intersecting lines. So what would be our conclusions? So the equations are independent, the system is consistent, the system has one solution, which is the point of intersection. What if A sub 1 over A sub 2 is equal to B sub 1 over B sub 2, but not equal to C sub 1 over C sub 2? Then we can say that this system, the graphs are parallel lines, which means the equations are independent, the system is inconsistent, this system has no solution. Lastly, if all the ratios of the constants are equal, and that would mean that the graph of the system are coinciding lines. They are on the same line, which means the equations are dependent, the system is consistent, the systems have infinitely many solutions.
If you learned something new today, kindly smash that like button. And in the comment section, kindly send me your thoughts about this video. Please don't forget to subscribe and share our videos so that I will be able to help you learn math lessons and concepts in an easy way. See you in our next video. Thank you for watching.